Time to take a look at a few graphs. So the functions we're going to graph here are going to be fairly basic. Our parent exponential, we're just going to use 2 to the x. Note that I could have used 3 to the x, 4 to the x, e to the x. We would have had the same shape either way, but I'm just going to stick with 2 because powers of 2 are something we're comfortable with. So if we want to start graphing this thing, we can build ourselves a table. I'm going to do that in this skinny margin right here. And we're going to start with x being 0. Well, if x is 0, that's the same as 2 to the 0 power, and that's just 1. 2 to the first power is 2. So the point 1 comma 2 is on that graph. 2 squared is 4. 2 cubed is 8. And that will be the last value that will fit on the right-hand side. 2 to the 4th would be 16, but we don't have enough room for that. If we go the other direction, start looking at negative numbers, remember those negative exponents give us fractions. So 2 to the negative 1 power is 1/2, which is right about there. 2 to the negative 2 power is 1/4. And note that my ability to do this accurately is going to get diminished very quickly. So here we have our parent exponential graph. A few things to note. This arrow does not go below 0. We have an asymptote there. Just like with rational functions, asymptotes help us determine the end behavior. So in this case, that left arrow is going to get really close to 0, but it will never equal 0. There's no power you could raise 2 to in order to get a 0. On the right-hand side, it shoots off to infinity. So when we look at our domain, I can put any x value I want into the domain. So the domain is going to be all real numbers. However, the range is not all real numbers. All of this stuff down here, that function will never touch. So we only get the positive numbers for our parent graph. One way we can write that is, well, 0 is where we start to see values, but 0 itself is not actually included. So we get everything between 0 and infinity. Note there is no equal to bar here. Because again, the actual value 0 is never going to come out of this function. So we're going to start looking at transformations. The transformations work the same on an exponential function as they have on all of our functions in the past. K is going to be our vertical up and down transformations. H is going to be our horizontal or left and right transformations. Recall those ones will be the opposite of what we expect. We'll look at those in a second. And then A can be our reflection, our stretch, or our compression. So all the transformations from previous units are going to come back for this unit. It's even the same notation, A, H, and K. So let's take a look at 1, which is actually marked in number 3. And note that this is our function. So if we're looking at it, there are a couple of transformations here. There's that +2 in the exponent spot. So that's going to be a horizontal transformation. And remember, it's the opposite of what we expect. It's a +2, so we're actually moving to the left 2 units. We also have that -3 on the outside. Again, that -3 is an up and down value because it's outside of the exponential. It's tacked on at the end there. And that works the way we expect it to. A -3 is going to take this thing down 3. So before looking at domain and range, it's helpful to have a picture. And I actually recommend using your calculator to help you here. because once we start translating these exponential functions, it can be difficult to find good points. So the y equals menu in your calculator will allow you to store any function you want. So we want 2 raised to the x plus 2 power. And then keep in mind we are going to subtract 3 from that. That's the function we're trying to graph. So I can get a table by pressing second, the blue key. Table is in the top right corner. And note that this gives me a good collection of whole number points. I can even scroll up to see a few more. Note that not every point is a good whole number point. Just like our parent function, there are a lot of ugly values here as well. So -2, -2 is a nice clean point. I believe we also had -1, -1 as a nice clean point. We also have 0, 1, 1, 5. And that is the last one that fits because 2, 13 will not fit on this graph. So we have a few nice whole number points. Now we want to let the asymptote help us. That down 3 is going to shift the asymptote down 3 units as well. So just like with rationals, you can think of an asymptote as a line the graph is not allowed to cross. In this case, the graph will hug that asymptote out to infinity, but again, it's not going to cross it there on the left-hand side. So now that we have a picture, we can say that the domain, well again, that's our x value, so it's going to be all real numbers. But our range is not all real numbers. It's everything from -3, not including the -3 because that's an asymptote. Everything from -3 out to infinity. So taking a look at this graph, I'll do 2 more in the next video. Double check that you understand where all the answers on those blanks are coming from, where all the points are coming from, and actually pull out your calculator. Make sure you can get that table. Make sure you know how to enter this function. And then once you're comfortable that you know where all this came from, go ahead and move on, watch the next video. I'll do one more simple transformation, and then I'll look at one with a reflection and a few other bits of fun. See you soon.